Let me tell you about Meter, the company rethinking network infrastructure from the ground up. Tired of juggling multiple vendors and fragmented tools? Meter delivers a complete networking stack, hardware, software, and services, all integrated to give network engineers the deep control and visibility you need. Thanks for Meter for making this possible. Go to meter.com/NAN to book a demo now. That's meter.com/NAN. Hello and welcome to the Network Automation Nerds podcast, where we explore the latest in network automation from a practitioner's perspective. I'm your host, Eric Cho, a network engineer who loves everything about network automation. Today, we're joined by Chris Kane, a well-known community member from his work at USNUA, Arista Networks, in various presentations at conferences. Recently, I had the pleasure of listening to his keynote talk at the inaugural Washington NUG event on Network for AI Park Dukes, where he talked about the explosion of stacks driven by AI in less than the blink of an eye. Chris is going to help us unpack, well, maybe I said all, but maybe some of the changes that will come next, because that was part of the theme of his network, but I'll let him to it. Most importantly, we'll explore the mindsets that keep you relevant, which Chris mentioned, intellectual curiosity and humility. I just love that term. Chris, welcome to the show.
Hey, thanks, Eric. It's great to be able to join you. I appreciate you inviting me on for the chat, and kind of a follow-up to having met you in person at the event in Seattle. And I think maybe we were first introduced at the AutoCon event in Denver. Well, actually, would that have been in AutoCon 2? Is that right?
Yeah, it was AutoCon 2. And like we mentioned in the intro, Chris, you're a prolific speakers. And so that was the first time I watch your talk on the great debates on, Wednesday night, a couple of beers and, a room full of network engineers. What could be better?
Yeah, it was a lot of fun. That was a reboot of trying to fire up engineers to have arguments over, my layer 2 leaf spine's better than your layer 3 leaf spine. Totally. It was a good time.
Yeah. I think it was fun in the way that it was friendly debate. And if I remember correctly, both of you work for the same company. So it wasn't really like a real, all out, fighting or something like that. No blood involved.
Right. But I think that's, we were trying to capture the banter that I think a healthy network team has, inside an enterprise organization. If you maybe have a couple architects and a couple, operators, and you debate optimal designs and, what could you do, what's supportable, what's available on the equipment that you have. Hopefully everybody has those kind of debates, right? Bloodless, no doubt, just stop the violence. But you should be hashing out, because I think if you stand behind a technology, you certainly don't want to be a zealot, but if you stand behind something, to be able to understand your position as well as the other person's position, why they're the pros and cons of the options that are out there.
That's a great point. And you speak like a true senior engineer, right? Because I, recently just signed up to be a mentor for this nonprofit org. And something we talked about that we want to teach the younger generation early on is that you could agree on how to disagree. And, you do have to have certain beliefs, right? All of us are driven by our beliefs. We're the sum of our experiences. So you do have some beliefs, but you could have a healthy debate, and that will foster collaboration in this increasingly polarized society of ours. That I think that's a crucial skill to have. So I really appreciate you bringing that up.
Yeah, and we hope that that's what a lot of people get out of the NUGs, right? The network user groups, that you were a part of getting that off the ground in Seattle there. That, hey, even to expand to a virtual team so that you can build, connections with people outside your organization to even help you maybe see more of the chessboard, right? A lot of us can get institutionalized with what we're allowed to do in our org, whether that's technology preferences or maybe it's, controlled by budgets. But hopefully people make those connections, not only at the events, but meaningfully continue conversations through Slack and other means that the USNUA has to kind of further your own education, right? Because, like you said, I mean, I started the event off in Seattle as like, listen, no single person can know all the things. Like that's just it's not going to happen, particularly
Yeah.
in this moment of explosion of technology that, you know, any of us involved with these particular projects are experiencing. So yeah, to practice some intellectual curiosity along with that humility that, hey, I certainly want to be a lifelong learner. I certainly want to hear how things are done. And then just recognizing that you just can't be the end all be all for these.
Yeah, for sure. So, Chris, before we get into your presentation and kind of the meat of our conversation, can you just tell us a little bit about yourself? How did you get into networking, and what drives you? Basically.
Oh, yeah, thanks. I kind of stumbled into it accidentally. I'm a college dropout. The in the U.S., the first Gulf War was going on when I was in
Mm,
school, and
right.
I just felt like I wanted to get out and be more active and do things. To say nothing of maybe seeing more of the world. So I joined the U.S. Navy, and I fell into a technician role. Is at the time it was called a radioman.
Hmm.
So we handled voice communications, data communications. So I was deployed on a ship, did HF, UHF, VHF, SATCOM type stuff, and realized I had an interest in technology. And so I got out of the Navy, worked for a phone company for about a year, and then was very fortunate. A friend of mine was working at CompuServe. So I'm going to date myself a little bit here, but to talk about CompuServe.
Computer.
But at the time, they only hired people through referrals.
Yeah.
And so I was able to get in there. And, they had different products. They had dial-up, they had X25. But then they started offering frame relay and IP services. And
Hmm.
Eric, the first moment I logged into a router, I was hooked. Like that's
Oh,
when
wow.
I fell in love. Was for all the different transmitters and receivers and radios and all those things. I mean, they were interesting, but the concept of a router and connecting the disparate networks together and sometimes having to translate between protocols, that was it. That hooked me. And I've been doing that now for, I mean, all told, it's probably a little over a 30-year career now to be in communications. And I think the underlying thing of this, what I've learned between that, career and then doing things like the network user group is it's just ultimately my North Star just seems to be flat out connecting people, right?
Mm,
Just being a conduit for people that, I know person A has an interest similar to person B. I absolutely need to connect them and get them talking, get them introduced. So, um, and now what really energizes me is building these networks for AI. We talk about there's kind of two sides of the coin. There's networking for AI, and then there's AI to be used in the network, like AI ops or leveraging an AI tool to help me manage a network. But building the networks to support these huge clusters has been super interesting because it's forced Ethernet to level up again.
hmm.
It's forcing, when you build at scale, you find things that don't break, or maybe you stumble across things that were minor problems at smaller scale, but when they get exposed to large scale, they really stumble, which
Yeah.
leads to innovation, right?
Right.
So to me, it's the innovation that's happening right now that sure, not everybody's going to build these ginormous clusters, right? Not everybody's going to need 6 gigawatts of power or whatever, but but ultimately Ethernet will be better and networking will be better because it's another proving ground. It's another place where the technology is pushed to its limits and really requires enhancements and feature adds. So I think every network engineer should pay attention to these builds because ultimately there's going to be features that will impact you, even as if you want to call yourself an average enterprise network engineer. There'll be features and solutions that will come about because of the extent that these networks are being pushed.
Yeah, there's so many good points that you mentioned, networking for both computers and networking for people. And you're
Yes,
trying to
yeah,
be the conduit for that. And
yeah,
also, kind of this, I would say bubbles, right? Like a lot of the innovations in the last few years have driven by the hyperscalers. They were pushing the boundaries, And I've often talked about like the origin story of S3, right? Like, if your hard drive fails at 0.00001%, it's not a problem for you as a home user or average enterprise. But if you're at the scale of AWS, then you're guaranteed to have a hard drive fail. You just don't know which one. So it's almost like the Russian roulette for data center tax, right? You're just hunting it down. And therefore that drove the innovation for S3, for simple storage service, but also because they have 3 copies of the same block storage all over, right? So S3. So I think you're right about the, just bringing it back to networking, that at scale, everything breaks, and that drives innovation. And you just mentioned Ethernet, and there's so many stacks has been impacted by AI. So in a nutshell, Chris, can you just, I think it's safe to say that most listeners were not at the WNUG, right? I have my fingers, I could count. And so in the, maybe 30 seconds to a minute, can you tell us what your presentation was about? Because it's part two, so I assume there was a part one, right?
Yeah. So, I've been fortunate through my day job to be adjacent to some of these projects several years ago. So started hearing about them several years ago.
Yeah.
And I'd say about 2 years ago, started traveling around the country to share stories about what was being built, what was unfolding.
Mm-hmm.
And so I'd done quite a few of the NUG presentations, or maybe other industry conference presentations, talking about what had been built. And then through that, we had learned, what we've picked up on is that we're tending to say now that the half-life of this knowledge is about 6 months. And so that it's about a year. Within a year, things change. I don't know if considerably is right, but a significant portion of the design philosophy, the approaches, or some of the tech that we're using as applied to these clusters, it changes fairly frequently. So that was the idea of the part two was, hey, if anybody had seen me here before,
throw that away.
Right? Let me give you, or anywhere, had on a podcast or anywhere else, let me give you an update
Right.
of where we are now and how things have evolved. And if you hadn't seen it, hopefully getting the audience to understand a sense of how fast some of this is moving. And so even if you weren't aware before, and you maybe had heard a little bit about 400 gig, and to hear, well, yeah, that's almost in a rearview mirror now. We're talking about, and have a focus on 800 gig and beyond in such short order. So that was the idea, Eric, behind the part two was, hey, here's where we were a couple years ago, and look how fast we're advancing in what we're talking about now.
So for somebody who were not there for the first part, and they're just coming in for part two, and what would you say the overarching theme is on, just besides things are moving super fast? What is the relevance of X, right? Like, you talked about the mindset, you talk about nobody can understand all. Then where will you start? How do you start?
Yeah. I think the first thing that stands out to a lot of us involved in these projects is, I guess if I could at least describe myself, being in networking for 20 or 30 years, I think you could probably describe me as a selfish network engineer.
And we talked about coining that term, right?
Right, selfish engineer. That's a new term. But what I mean is I really only cared about the networking. I wanted to go deep as possible into the networking, understanding the silicon and the optics and the bits, and just to be a master of that domain, is the goal. But here, I think what we realize is to really establish your ethos and to really understand what's happening, you've got to have an appreciation for the adjacencies, for, hey, what's going on in the compute? What are these accelerators about? What's happening with storage, and how is it evolving in these environments? So I think you find yourself paying more attention to power, right? Power, you joke that power is the nucleus of every one of these designs, because you got to figure out where you can actually power the racks,
right,
and cool them. With all the equipment involved. But, so you pay attention to power and into the facilities more than we have before. I pay attention to compute. I find myself actually interested in what NVIDIA has to say and what AMD has to say, and Intel, and where are they going. Where before, I mean, frankly, I just didn't care about CPUs or accelerators or even storage all that much, except, for those few times I'd get involved like an IP storage project. any convergence of something onto Ethernet then. But I think that's a big part of, even before you get to the new terms that a network engineer has to know. I think realizing that, hey, you should spend time with your technology peers, talk to the compute team, talk to the storage team, find out what's going on, and even an element of talking to the data scientists and the application owners.
Yeah, absolutely. I think you need to get out of your cubicle, get out of layer 3, layer 4, and then you got to
Exactly.
work
Right.
up and downwards, right? Like you got to get down to the physical layer. And that just kind of brought me back into this time when we're building, hyperscaler data centers, and we have these proposals for locations, and because the budget wasn't constrained, so we have all of these locations in. Let's just safe to say they were not connectivity friendly, right? They were just like in the middle of nowhere, in not the New York or San Fran, these area where have high density where we could easily peer, rather than in just the middle of nowhere. And I was kind of puzzled as a young engineer on why did they pick these places where it's so hard, and it costs probably 6x 7x just for normal connectivity, and in some instance you have to go trench out the fiber and all of the associated timeline and delay and risk. And of course, as you mentioned, Chris, that it's the power that drives everything, and how much if you lose 50% of it by transmitting to that another location, that's just not going to work. So all of these are just driving center around power, but to a certain extent cooling as well. So all of these stuff just drive back to your point about you need to go out of your cubicle, you need to go communicate with your peers. You cannot be a SNE, right? Selfish network engineer anymore.
Yeah. Look at that. We not only coined a term, you gave it an acronym already. Well done.
Yeah. So just want to let the listener know as well. I think this is one of the podcast episodes that really helps to have visual. I mean, obviously we'll present it in the audio experience, and we'll try to describe what we see on the screen, but it will really help sometimes, right? Like if you have that presentation in front of you as well. So for this episode, if you prefer, you could also watch it on YouTube. I'll release it on my channel or Packet Push's channel, but don't, or you could go download the presentation itself in the US NUG Slack channel, where Chris have generously shared this deck, and so either way that you could follow along. So should we just get into the presentation itself?
Yeah, absolutely. So we talked about you have to be aware of the adjacent technologies. I think the likelihood of your success in these deployments. To throw out another new term, time to first token is yet another new term that's been
shared. Instead of hello world, it's time to token.
Time to first token, which means a lot to different people, whether it's, hey, we're just getting the gear powered up, right? From when we ordered it to when it's installed to when it's actually moving production packets, it could also refer to the kickoff of a job as well. Mm-hmm. Part of the due diligence I think a lot of people can do now is start to get familiar with the technologies involved here, where I have a bit of a homework slide that I always share about. Here are the topics I believe an average network engineer knows and has probably worked with.
Right.
But what are the new terms to be introduced? And it can be overwhelming. I wouldn't want to be a network engineer that goes to a first meeting for a project that they're trying to get into the production in just a couple months, right? It's a huge learning curve to understand what's prioritized in these builds and what the expected outcomes are. So for a network engineer now to, even if you're not working with 400 gig or 800 gig just yet, just to have an appreciation for what's going on with the SerDes, and interconnect speeds, right? A lot of us may not historically kind of looked inside of a switch to see really how's that silicon work? How's the optic and the electrical setup of getting from the silicon to the front panel port to our optics and our interfaces, and paying attention to things like encoding. Maybe we weren't really paying attention to anything outside of NRZ, non-return to zero. and that there are other encoding schemes being leveraged now, whether that's PAM4, PAM6, some of the other ones they're experimenting with in order to get reliable higher speeds.
Hmm.
And there's other developments there, like the co-packaged optics, the linear drive optics or linear pluggable optics that are coming out. One thing that really hits network engineers in these builds is the concept of over provisioning,
Hmm.
because we have all grown up in this industry living by oversubscription, right? Like
Right.
we knew people aren't going to use all the available bandwidth all the time. It's just not likely to happen. And there's so much, less maybe machine to machine and way more what we'd call north-south traffic with humans interacting with the data. And here there's just so much machine to machine traffic, or what we like to call east-west traffic, that we can't have a 3-to-1 or a 5-to-1 type of oversubscription ratio in the infrastructure.
Yeah.
With these builds, you try to do everything to make sure that these accelerators are in use, that they're being productive, because they're incredibly expensive.
Right.
Any single accelerator could cost $20,000 or $30,000, and there's at least 8 of them in a host system.
Wow.
If you look at the vertical growth that's happening and the scale up concept, NVIDIA's got that NVL 72 where they've got 72 GPUs and 36 CPUs in a
Oh,
single.
wow.
Right?
It's just going to
So,
melt.
yeah, and you think about, okay, well, those things are several $1 million for the cost of one of those racks. So idle time for the GPUs clearly a bad thing,
Right.
and so we over provision the infrastructure where we provide at least a matching ratio, 1-for-1, of the bandwidth that we connect to the compute or to these NICs where the GPUs are at. We make sure there's a matching amount of bandwidth between the leafs and spines, like in a Clo fabric, whether that's a 3-stage or maybe it's a 5-stage because it's so big that you need a super spine. But we actually have to provision a lot more bandwidth than we have historically. And that leads to increased cost, right? If you
Yep.
look at the CapEx side, it's not the normal budgeting process that you would have in just like a standard data center refresh or a greenfield data center build.
Hmm.
And then on the operations side of that, you grow an appreciation for how often you're going to have failures. Kind of back to your example of the S3 and storage and disks, and in these environments, you could have optics with a mean time between failure estimated to be 5 years.
Right.
But when you get 20,000, 30,000, 100,000 or more of those into one cluster, you realize that, hey, we're going to have a failure like every hour. An
Hmm.
optic will fail constantly, like links are going to flap. And so you take a hit on the CapEx side and the design and the budget, and you take a hit on the OpEx side. And what are we doing for observability? How can we isolate the trouble as fast as possible? Rule in that or rule out that the network is to blame. But a lot of that comes from this over provisioning concept that we have. And then you get into things that are like, hey, what's going to be on the wire, right?
Hmm.
Am I going to see a bunch of TCP traffic and like TCP sawtooth type things? And actually, no, here you're going to see a lot of RDMA traffic with UDP, Rocky V2 encapsulation. So that's another piece where understanding what's going to cross the wires and then thinking about your NMS tools, thinking about your packet capture tools if you have them. Do my tools understand these protocols? And so that's another element of kind of an audit that you should probably go through as you start to engage in these kind of projects, or if you're trying to do some due diligence and homework before someone comes knocking on your door about these. QoS is incredibly important here. I would say, before this came along, Eric, I don't think I did QoS in a data center in probably 5, 7, maybe even 10 years. We've been able to throw bandwidth at most of the problems, right, in a data
Yeah,
center.
for sure.
But here, the contention is really high because those compute resources are going to use every bit of bandwidth that you give them, and it's going to use it for extended periods of time. So now all of a sudden, we really need to have an understanding of what QoS tools does each vendor provide you. Whether that's priority flow control, whether that's explicit congestion notification. And then you get into other elements of, we need much better load balancing than maybe we've had historically. load balancing that's much more aware of what the traffic actually is. So I wouldn't call it deep packet inspection, but there's some element of looking inside the packet to understand what that traffic is to aid in the load balancing. So yeah, a lot of terms, a lot of homework for folks to do that ultimately should be done before you work on the design, because you need to make those items required criteria as you do your networking vendor selection, right? You want to make sure that, hey, I'm buying products that support the needs that these projects are going to bring.
Hello, here's something that will resonate with network engineers everywhere. You know the frustration, managing networks across multiple sites with different vendors for switching, wireless, and security. When issues arise, you're jumping between multiple dashboards and vendor support team just to figure out what's wrong. It's inefficient, and frankly, there's a better way. Meter took a different approach. They designed their own hardware, write firmware, and build software stacks that gives you full control and visibility. Everything from ISP procurement to security and SD-WAN, all in one integrated stack. Here's what I love. They're not dumping down networking. They know you're problem solvers who want control. Their approach empowers you to be more productive with deeper network insights, whether you're managing branch offices or large campuses. Thanks to Meter for making this possible. Go to meter.com/NAN to book a demo now. That's METER.com/NAN. Now, back to the show. Yeah, so Chris, I think just from your description of the homework, right? We haven't even gotten into the technology, but just from the description of the homework, it almost seems like we have this double whammy where, before it was the commoditization of your compute power, the storage to a certain extent, that we have this explosion, but they're commoditized. So we are able to, kind of spread out and do the oversubscription, and we're able to have like a fleet of servers that for a service, but they're redundant to a point where we could, tolerate a few failures. But now that, yes, we're going to have like 5x, 6x more of that, if that, and the tolerance for loss is so low, the reliability requirement is so high, and these units are so expensive, so much more expensive than everything else, that an idle GPU is, just kind of money blind, like your hole in your pocket, right? Money just falling out of it. So it's like, oh my God, it's like two at the same time. So all of these new terms, it seems to be just tailored because we have in this environment. I don't know. So yeah, okay. I get what you're saying. And what's the next step? After we get the homework, what's the next step?
Yeah. So definitely start doing the homework, paying attention. I would look at whatever your preferred networking vendor is, start watching the release notes of each of their, software releases or their hardware releases, and be on the lookout for some features that are coming that, would be, they're aimed at solving those problems, but can be applicable to solving problems you have every day. And a lot of that will come out of, to give you a specific example, would be the Ultra Ethernet Consortium, the UEC, right? So the UEC, to me, it's a body similar to the IETF or the IEEE. It feels more like the IETF, where, they've come out with recommendations for a standard and updates to Ethernet. I think it was released in 1.0 spec was released in June. And it's about 500 pages of enjoyable reading about language similar to an RFC, where it's should, could, must not, type of language in there. And there'll be features coming along like packet trimming, link local retries, kind of up the from the physical layer to the transport layer, enhancements that'll show up either in the networking switch or will start showing up in NICs, right? I think NICs are going to be an area of contention in regards to demarcation of ownership.
Right.
So in other words, like if I'm the server person, I'm making a purchase, and I pick a smart NIC that's capable of EVPN VXLAN, where it can be a VTAP and it can do this reassembly and it understands RDMA and Rocky V2 and it helps accelerate that. Or even has IPsec or MACsec capability. I think that becomes an area of increased discussion, between a network team and a compute team, to think about what capabilities are they looking for in those NICs, and then who should have responsibility for
Right.
that, right? Should it
Right.
be the network team or should it be the compute team that either buys it, tests it, operates it? So again, once you start doing that homework, I think you start, go have a lunch or a coffee with some of your technology adjacent peers to see how things are progressing with this tech on their side.
Yeah, I think SmartNIC it's not doing its justice on like how much processing we're doing there, right? Like so you have your CPUs, you have your GPUs, but now you have your NPUs, right? Like your network processing unit. So I think I personally prefer that term just to separate myself out from like all the smart-ish terms. But yeah, you're right. I think that's going to be the next demarcation because of all the virtualization and how that bringing closer to your compute. If you don't even have to go out of your server just to have like multi-tenancy within your 200,000 US dollar server.
Right, right, exactly. Yeah, and then once you start doing that homework, you start talking to some of your peers or maybe some of your vendors. A lot of people ask, well, what's the likelihood of this hitting me at my organization, right? And that's why
Right.
we had talked about crossing the chasm,
Yep.
stealing that phrase from incredibly good book. But where were we before? A few years ago, it was the cloud service providers, right? The kind of the usual suspects, if you will, that were building these clusters. And then there was a new category of cloud service providers that popped up that people refer to as neo clouds. So if you look at if you
Like,
categorize service providers as tier one, tier two, tier three, I think
mhm,
neo clouds is a way to describe more of the tier two, tier three role of folks that are offering GPU as a service.
mhm, like the core weave. Would you
What
classify the neo
spot on,
cloud?
CoreWeave, yeah, great
Yeah.
example. Um, and so we certainly saw that adoption. And now what we're seeing, if we say, hey, all right, where are we at this moment?
Right.
We're seeing this with large global enterprise. Global financials are in the middle of these projects now. We see high frequency traders
Hmm.
that probably had an HPC like or maybe a CPU focused cluster that they were using before. They're now adopting the idea of the accelerators and GPUs in their use cases. You certainly hear about it in life sciences and big pharma and everything around medical development. And then higher ed a little bit because a lot of the higher ed research centers, they're trying to attack talent. They're trying to solve real problems, and I think they're beginning to look at this to move from a CPU based cluster type solution to some of these accelerator based ones. And then you have the global automotives.
Hmm.
And I'm not sharing anything that isn't publicly available that people talk about, but you certainly see the automotives getting there, where whether that's all about self driving vehicles or not, or if it's bleeds into their manufacturing processes as well. But those organizations are certainly large enough to support these projects. So that's what we're starting to see now. I think next year we'll see more on premises builds. More of it, people have had time to test their applications or their use cases inside of a GPU as a service type solution. Like maybe they went out to Oracle, rented a cluster for a couple months,
Hmm.
kick the tires, and then get a real feel for what they would need for their use case, and therefore they could right size their cluster build on prem to be more applicable to their use case without breaking the bank.
Yeah, I love talking to cutting edge vendors because you almost like the hard work has been done. I just
Right.
have to go steady, right? Like imagine the vendors who maybe 2 years ago or even 6 months ago they were trying to solve these problems with a blank slate, and they're just like, okay, what do we do now, right? Like I'm pulling my hair out. But back to what you were talking about, crossing the chasm. That was one of the eye opening moment for me out of the presentation, is that we've crossed that chasm, right? So for people who were not familiar with that term, it was, you have these early adopters who were, kind of, as you have on the slide, 13% of the overall generation, for overall population. And then you have the early majority, which is like, 30, 33%. And do you think we've crossed that chasm, that now that we're at the early majority, that this are not just a monopoly by the hyperscalers. These are the high frequency traders, life science, big pharma, higher ed, and global automotives.
Yeah, absolutely. We're definitely seeing them build. I mean, they have to solve their power problem first, right?
Right.
That's one of their first steps for them in these projects is to figure out if they have sufficient power with the existing data center space that they use today,
Yeah.
whether that's data centers that they run themselves on their own property or maybe they rent from a colo. So some of them have to go out and find other colo providers that has enough power.
Which is a huge problem in itself.
Yeah, it's a big deal. I mean, going again back to the Navy days and thinking about nuclear power on submarines and their ability to miniaturize that and control, nuclear to be a legitimate source of power. And
Right.
hey, let's just take that and plop it, just outside the data center. Let's run the data center off of that too. In
Hmm.
the concept of SMRs. So yeah, it's a whole nother area that's people could get interested. Just like liquid cooling, is another one where historically everything clearly has been air cooled
Right.
for us. And now we're looking at liquid cooling. And people would say, well, the network equipment in and of itself doesn't need to be liquid cooled. It doesn't generate that much heat.
Hmm.
But when you're being put in racks adjacent to these other technologies, a lot of the ask is, hey, could you provide me the same model switch, but just make it a liquid cooled switch instead of an air cooled switch so that I can put in the same areas as this other gear.
I
So that'll
see.
be another evolution that all of us will watch the network vendors here. I'd say over the next 3 quarters,
Hmm.
you're going to see a subset of everybody's product line is going to offer model versions that support liquid cooling as well as the air cooled. So, yeah, yet another adjacency you can get into if that tickles your fancy.
Yeah, that's so interesting because I remember having to fiddle around with SKUs that specific for like front to back, back to
Yeah,
front.
yeah, yeah,
And
right.
then,
No, you're absolutely, dude.
uh,
Eric, I will tell you the number one cause in my day job. The number one cause for RMAs
yeah,
is incorrect airflow.
right,
Right, we just ordered it wrong. It was to your
right.
point. It was front to back or back to front, or front to rear, whatever you call it. But
Yeah.
yeah, like, we're just going to make that problem worse. So,
It's
you
like
know,
now it's a double, but it's like liquid cool, but like a front to back. I don't know, right? I don't even know where to begin on just
right?
coming out with the SKUs. I guess it's good for the person who's doing the SKUs, right? Like job security for him or her, or unless
Yeah,
it's an AI doing it now.
yeah, yeah, right. AI maybe help us with those designs, but yeah, there'll be more. And you see that with the optics too.
Yeah.
If people felt like they were comfortable with the form factors of 25 gig and 100 gig, moving into 400, 800, 1.6 is right around the corner next year. And then I think they have line of sight to 3.2 terabits. The way those are built, the way the SerDes are laid out, whether you're at 112 gig, 224, 448, um, there's an interoperability problem or could be an interoperability problem. So now we have to pay close attention. It's maybe easy enough if it's just like a leaf to spine. I own both ends of that connection. But as a network person, if I'm connecting to compute, I do need to start asking my compute partners, what's the encoding you're using? What's the signal rate that you have? Because I want to make sure I get a matching optic for that. So we've I'd say, I feel like, I don't know the exact number, but I feel like we've quadrupled the amount of optics that are out there right
Oh,
now,
for
right?
sure. Yeah.
It's not just QSFP DD, the double density, but it's also, OSFP as they are today. And then even inside of each one of those, you have, hey, is this 8 lanes of 50 gig, or is this 4 lanes of 112? How is this comprised so I can ensure interoperability at the other end of that fiber?
Yeah, I remember just sitting in a college lecture not long ago, maybe a couple months ago or late last year, that they were talking about, they were experimenting between inter data center cloth fabric
Mm.
and using tunable optics, right? But for DWDM, but the problem is these tunable optics is tunable to like 4 wavelengths, right? So then, oh my God, it's just like operation wise, obviously it was in the lecture. So in theory, we could all make it work. But imagine you're that data center tech who's trying to find that right optic to like swap out in the middle of the night across data center, right? So those are the kind of adjacency that you talked about, where you could go up the stack and talk about application, all the exciting stuff. But hey, if you go down the stack on the physical layer, how are you going to make it work just by this explosion of SKUs and operationally, is that even feasible?
Right, right. Well, and we talked about this is distributing computing like we've never seen before.
Yeah.
And so, again, maybe not applicable to everybody, but some of these clusters, they are so big that one data center or one data hall can't hold all the endpoints, right?
Right.
There isn't enough power, cooling, and fiber inside of an individual building. So some of them are, building now multi floors for their data centers, or they'll build multiple data centers on the same campus.
Hmm.
And now you get into that idea of, we've got scale up, which is that verticalization inside of a rack, right? And then you have scale out, which is what network engineers have been kind of used to. We've lived with
Right.
scale out for a while, but then,
Right.
as NVIDIA would like to term it, they've come up with this concept of scale across. Which for us, all us networking people are like, yeah, okay, that's not really new. That's called a data center interconnect. Like, oh, we've been doing that for right. But there
Something we
is,
could teach them back.
yeah, but it is a thing now where like, hey, I need considerable or could need much more bandwidth between these facilities than I'd had before. I mean, we even see it in higher ed and HPC's, involvement with Internet 2 and others, where it's not just distributed inside of a data center, but they are trying to cluster or distribute these across data centers, which means
Hmm.
it's gonna extend even beyond a campus, right? It's gonna be miles, it's gonna be state adjacent, it's gonna be across the country. And so, yeah, getting more bandwidth, getting more bits shoved onto that light, we're definitely be looking to do. Yeah, I'm with you. I don't envy the engineer that's just trying to find the right frequency tuned optic, right, for what
Yeah.
they're swapping out. But yeah, these the advances here hit everybody. So maybe you are a physical layer specialist. Your patch panels are going to change. Maybe your approach to using multi-mode fiber versus single mode fiber, that's likely to change here. Where a lot of people see single mode fiber as something that's lived a lot longer and is usually the first attack vector when it comes to speed transitions. So a lot of times we see them adopted on single mode before we see them on multi-mode.
Mm.
To your outside plant person with their OTDR and what they're going to be troubleshooting and looking at when you talk about aggregate links, I mean that's clearly where we need the most bandwidth. So 800 gig in the outside plant, 1.6 in the outside plant. Those are going to have impacts to those individuals as well.
Yeah. And to couple what you were talking about earlier, right? It's not just throwing bandwidth that you could get the first bit across. It's that high reliability. If you mess that one bit, you have to go retrain the model or whatever it is, right? Like whatever that reason behind it, it's that beyond 5 nines of reliability, like maybe 6 or 7 even. So, and then imagine doing that across like a busy traffic street or like I can imagine. But it's all right, let's just assume, we've done the homework, we know the terms, we talk to our peers, and up and down, getting out of my cubicle, never eat alone. And then what's next?
Yeah, next is I think thinking about observability and thinking about day two. So, we
Mm,
spend a lot of time thinking about day one,
right.
but clearly we live in day two, right? That's where the life of all this is. And so thinking about visibility or observability, I think is important, which backs into, hey, understand what's going on inside of these systems. So,
Hmm.
whether you're NVIDIA with NVLink and NVSwitch, or maybe it's an AMD build where Xfinity is there, or maybe, in the near future, it could be UA Link. Maybe it's Broadcom's SUE, or what they call scale up Ethernet.
Hmm.
There's connectivity that an average network engineer wouldn't have visibility to normally.
Yeah.
Right.
Yeah.
So if somebody were to call and say there's a problem, my inclination's to jump, okay, let me just jump on the leaf closest to you and figure out what that leaf says is going on. And then I'll walk the network and figure that out. Or I'll look at my NMS tools to figure that out. But they're likely looking at my switches.
Yeah.
They might not have visibility into the hosts or the nodes themselves. And so to have an appreciation, again, spending time learning the adjacencies is to learn that, hey, inside of these systems, whether it's, like a 4RU type size server or if it's a whole rack, there is interconnectivity between the GPUs within those systems. So somebody could have a communication problem that is impacting a job, But if I were to go run a TCP dump on the first hop leaf, I'll never even see that traffic. It's
Exactly.
conceivable that it's inside the host. So thinking about, hey, what are we going to do for visibility? Again, coming back to maybe what's the demarcation of ownership?
Hmm.
As a network person, could I ask a compute person to send me their Prometheus feed so I can incorporate it into my preferred NMS tool, right? Just
Yeah.
to get a little more visibility about what could be happening with the communication path inside that host or the memory or the CPU. You definitely want to get more of the picture as you're troubleshooting that. Then again, compared to what you normally had done in the past, where I could say, hey, my area of responsibility stops at the optic on the front of the switch and then I'm done. It's somebody else's problem. And I think that in these environments, you really don't have room for that. And that you've got to have an appreciation for what's going on inside those hosts as well. And then how that'll change over time as we get into the scale up, where there's going to be not only like single rack systems, but NVIDIA's proposing multi-rack systems, and I think we see some custom builds. I think Google's been fairly transparent about their TPUs and how they build their racks, and Microsoft Azure, I think they've a lot of public information out there about their custom rack builds that ultimately, the entire industry is paying attention to and will lead to enhancements that, again, yes, the early adopters are doing that now, but it'll have implication to you, within the next 18 or 24 months.
Yeah, if I were to able to describe a little bit on the last slide that you have on what you're showing, I think that's a H100 that you listed out, that
Yep.
there's 8 GPUs that's kind of cross connect with each other, not full mesh, right? But then it's connected to each other, and then you have 2 CPUs that's kind of arbitrating, like the workloads or whatnot. So one question I had, Chris, is I don't know if you have the answer, but how do you like what you described, right? Like, how do I troubleshoot the interconnect between GPU 0 to GPU 2, which was the two, upload most when I'm looking at the screen? So how do I troubleshoot that? And is that my demarcation, or is that just a collaborative effort, like you described with the server team? Because they might understand workloads, but they don't understand, like the traces or the encapsulation, all that, all those
Right.
networking terms.
Right. No, totally. Just as we don't understand theirs, you're absolutely right, Eric. A lot of times they don't understand our terminology and our priorities. But yeah, each one of these accelerator providers, whether it's NVIDIA or AMD, they have their own tooling, right? Their
Yeah.
own monitoring systems. What I've run across frequently is
Hmm.
Prometheus seems to be a popular tool for a lot of these deployments.
Got it.
And so what we've asked for in a lot of scenarios is, hey, send your Prometheus feed to me, to
Hmm.
my NMS system, so that I can see that. And then that will help me, let me look at your syslog. Let me see if you're logging things like memory errors. Let me see if you're logging errors with the NV link, or maybe it's the NV switch inside of that host. So a lot of it is, you give me that visibility, even if it's only read only.
Hmm.
That not only with the system, but that's true the NICs. Coming back to the NICs being smarter, right?
Hmm.
NPU, IPU, DPU, whatever you want to call it, whatever acronym an OEM throws on there. But those things also have the ability to report to me their configuration, to report to me their statistics, right? So again, being on the other end of the cable connected to my equipment, I would love to see. Let's double check what is the config on your NIC.
Right.
Are you do you have ECN enabled? Are you reacting to the CNPs that are flying around because we are seeing congestion? Are you properly marking the no drop class priority in the PFC of your frames that you're sending across to me? So that's a collaboration thing. As far as the demarcation point, that's probably will vary by organization, as far as how collaborative or maybe the animosity that exists between a network team, a storage team, and a compute team. But clearly, I mean, more visibility to better, right? Sure, I guess we could be inundated or overwhelmed by too much information, but I would rather have clearly I'd rather have too much than not enough when it comes to trying to resolve these issues as fast as possible and figure out where the fault really lies.
Yeah, meantime to innocence. But it's almost from your perspective, Chris. I guess this was just a question that came to my mind as you were describing it. Is there any movement on standardizing the inner bridges or inner interconnects
Oh,
of the servers? to, kind of having that visibility. So I don't have to be logged into the NVIDIAs or AMD of the world.
There are proposals out there.
Okay.
There's UA Link, right? So UA Link is trying to put forth a standard for these interconnects. AMD's been very vocal about being supportive of UA Link. Another one would be Broadcom put forward Scale Up Ethernet, or SUE.
Okay.
Is another thing I think would be available and something you could reverse engineer and truly understand. In other words, it's not a black box, right? And to be transparent about what that is. I mean, and that's the biggest part of all these things is, we don't want opaque solutions. Like I want to be able to take the lid off the box per se and see what's going on inside, because there are communication paths there. And so with UA Link, I don't know how NVIDIA is doing as far as the adoption of that. I'm sure they face the challenge of they're moving so quickly and getting so big. And by big, I mean, the NVL 72 to the NVL 144 to the NVL 576.
Yeah.
That, they likely need to solve problems faster than a standards body is going to, provide a ratified standard. We saw that with speed changes when we went from 25 gig to 50 gig to 100 gig. Every one of those was some sort of multi-source agreement, or what they call an MSA, right? It was a consortium of vendors to get together and hash out, maybe during our day jobs, we're enemies, we're competing with one another. But listen, we have to be interoperable. It absolutely has to happen. But sometimes the standards bodies can't move fast enough for that. And so it's, I would say it's not uncommon to see people provide a solution for the near term and then maybe turn over that technology or open it up so that it can be adopted by everybody else. And we certainly hope to see that happen, whether it's UA Link or another solution. But to move away from the proprietary would certainly help all of us.
Yeah, I would agree. And I think, it's just sometimes, unfortunately, or, reality is that observability is just an afterthought, right? And interoperability was never a good mechanism for making money for that vendor who's, trying to sell you the proprietary information.
Right.
So we're all very familiar with that process. And, it's good that there's movements and at least some sort of discussion over it. But I totally understand the fact that we have to move forward, we have to solve the problem. And these observability thing was just kind of an afterthought. So
yeah.
Yeah.
Well, I would throw out there too, Eric, if we could, talking about proprietary stuff, one of the things that came up very early on a couple of years ago was InfiniBand versus Ethernet.
That's right.
Right. Is another area. And, they're just, Ethernet's everywhere, right? And we've seen Ethernet adapt. We've put voice on Ethernet. We've put storage on Ethernet. Right. If you look at the media companies, a lot of them have moved from analog solutions to Ethernet to carry their voice and video. And it was a religious battle for a little while. And then, I'd shared during the presentation that Del Oro had published a report last October that they expected more Ethernet ports to ship than InfiniBand ports, and they estimated that to be sometime in 2028. And then this past February, they had updated that and they pulled it in by a whole year and said, oh, Ethernet's really moving, and we're seeing it in the front end and the back end, and therefore we think the total number of ports shipped of Ethernet will exceed InfiniBand in 2027. And then, Eric, I think it was a week, maybe two, after we saw each other at this event, Del Oro, at an OCP, an Open Compute Conference, Del Oro published an updated report where they pulled that in to this year.
Oh, wow.
2025. So we went from 2028 to 2027. They said, the hell with 2026. 2025 is going to be the crossover. So, whenever that lands, the point being that ultimately, I think proprietary solutions can get you off the ground, but when you're really talking about a whole community that needs to support this, when it becomes more common, when it crosses that chasm and it's not so niche, then we really need to be leveraging technologies that everybody's familiar with and that you can source from multiple places. And I think that's why we see Ethernet, coming to a prominence now.
Yeah. I guess we could say the same thing about BGP. It's just like, some other technology. I mean, pick your religion, right? Like that might be technically better and more whatever you define better as. But at the end of the day, we'll have to work with each other, and we rely on our common denominator, in this case, Ethernet and BGP, maybe something else. But yeah, that's a great point.
Yeah, well, I think I think it's a reminder of if you look at the IETF and you think about RFCs, there is this concept of BCPs, right? Best current practice.
Mm-hmm.
And to take your BGP example, years and years ago, we would have had arguments, an IGP is faster, right?
Convergence.
I like my OSPF, I like my ISIS, maybe you like the proprietary solution of like an EIGRP, whatever. But, you would say, hey, just as when you look at BGP and realize how prolific it is now, it is everywhere. People are putting it inside the data center. People are putting it inside their campuses for routing when they need it.
Inside the car.
Yeah, right. So I think all of this, as you look at it, like InfiniBand, same rule would apply where it's, I think you have to ask yourself, why do you believe what you believe? And is that a fresh perspective? That maybe you had a best practice or you had a preference, but you might want to revisit what those preferences are. Like, hey, is my opinion here dated? Has something changed? Has the technology evolved? I mean, look at BGP. I mean, I make fun of all my service provider friends that EVPN, VXLAN feels like a service provider technology now, just because there's so many acronyms and so many add-ons, and so many, route types that are being thrown in there. But to recognize that, maybe if you were anti-layer 2 extension before, now revisiting that, okay, there's some technologies that help support this concept. Same thing with the BGP. And then I would tie it back to this conversation of InfiniBand that, yeah, at one point, it made total sense to be all in on InfiniBand. That was the preferred technology to use, but, reboot that opinion, especially after the UEC. And once we start seeing UEC features deployed in NICs and switches, that a fresh perspective may change your opinion.
Yeah, I like how I know we're not going to cover even half of the slides and, even the beginning, but I like how you kind of fast forward a few of the slides, but kind of capture your original idea about intelligent person that needs to collaborate, and then kind of bookend it with fresh mindset and these question your own beliefs on whether it's still valid or not. So how do you? So I guess in the interest of time, right? Like we need to wrap this up at some point, but it's so interesting conversation. I wanted to ask, how do you be non-argumentative, but still have strong belief in what you believe in, that you're able to go out and defend yourself, but also easily be persuaded when data presents itself? So how do you do it yourself, Chris?
Yeah, well, I probably have to stop and think, am I not argumentative? I probably should check with my peers.
That great debate,
my coworkers, and make sure my coworkers agree with you that I'm not argumentative. But no, I do like the term banter.
Okay.
I think banter is a little more diplomatic way of looking at, how do we discuss and work through these? But I feel, it starts with trying to be honest with yourself of, okay, I have an opinion, but have I done the homework to have an opinion? I think a lot of smarter people than me have talked about in the past that, you're in a good position to have an opinion if you understand the opposition's argument better than they do. Right. I think that's a piece of it. Right.
Yeah.
So trying to do that homework, or, maybe you have an opinion, but then you got to realize, okay, I have to test my opinion, this hypothesis against some real world scenarios and see if I can break it. In this context with these technologies right now, with building these networks, it is definitely something that takes nights and weekends to keep up with. So I think another part of that, Eric, is you can't be a 9-to-5er, or it's unlikely if you're a 9-to-5er that you're really going to really understand the lay of the land here. I remember I talk about Bell Labs all the time, where there was an approach at Bell Labs many moons ago that, hey, you get paid for what you do from 9 to 5. But you get bonuses, raises, and promotions based off of what you do with the rest of your time. And I think there's an element of that here too, that this is so fast moving, right? There's so much stuff. Like we had even listed out during the presentation when we were together, just just trying to take a swag at some of the new things that are out, and how they evolve with each release of code or hardware. But that I think, overall, realizing that in order to see what's been tried, what's been tested, what's been found out to work. I think just it takes extra hours, right? It takes extra effort. Maybe if you don't believe in the extra hours, it certainly takes extra effort. And again, I would tie it back to community too, Eric. That okay, if I can't read all the things, if I can socialize with other people that are reading the things, then through them, I can get trusted sources, right? I can get information. So I tie it back to the NUGs and the network user group, that hopefully I'm interacting with other people that have these similar interests, but they can bring like a Reader's Digest synopsis to me, right, of something. So, hey, I don't have time to read the 1,000-page book, but if you could summarize a chapter or two for me, I'd certainly appreciate it. So I think community helps. I think, the idea of being the lone wolf doesn't suit you here. It takes a community to keep up.
Don't be a selfish network engineer.
Don't be a selfish network engineer. Right. Perfect. We tied it right back to
whoever is doing marketing should reach out back to me, because I always reinforce the message, right? But
trade marketing. Yeah, totally.
Exactly. I like everything you said, and I will also throw in, I don't want to sound old, but time, right? So I think, just comes with time. When I remember as a young engineer, I was, defending XYZ technology. And of course, later on, I needed to take my foot out of my mouth. Then I learned, and, don't be so narrow-minded. Don't have your blind on and just look at this thing that you're looking in front of you. Don't treat it as a religion, and treat it as an opinion that could be easily moved if you're proven otherwise by data. So yeah, everything you said. And I also like the fact that you talked about NUG, because you could try to read everything comes your way, but you just won't have time to live your life or be a good father like, I'm trying to be, or,
Right.
Hang out with your friends. So definitely, so let's bring back to NUG on how many states are NUGs in, have a footprint in nowadays. Do you know?
Oh yeah. So we're over, I think we have around 35 active groups now around the country.
Awesome. Yeah.
We had started at the state level. And then as it grew, we realized people wanted an increased rate of the events, increased frequencies. And so we've started to move it to the city level.
Mm-hmm.
So we had, it started as the Ohio NUG or the ONUG, OHNUG. And we would rotate cities, and now we have specifically a Cleveland chapter, a Columbus chapter, a Cincinnati chapter. We see that in Michigan as an example. There's the Eastern Michigan group, more of the Grand Rapids, more of the Detroit side, and then a Western group for Grand Rapids. Texas, we have multiple groups there, Cruy, to cover all that geography.
Clearly, Texas is so small that, no, just kidding.
Right? I know. All my friends in Texas would kill me about the idea of, hey, what, you can't just travel from Austin to Dallas for a 4-hour event?
I know, you could practically walk there. Come on now.
Right? Yeah. So, yeah, it's been great. It's fantastic. We have additional back office help now. We've got Jess in marketing. We've got Kayla helping with all the events. We're definitely maturing. And then again, building a network, Eric, I'm humbled by the connectivity we have now with packet pushers, Ethan Banks, right? Drew,
yep.
With the Network Automation Forum, and Scott and Chris, Scott Roban and Chris Grunderman. Again, even for us that are trying to, push the idea of building networks, we're eating our own dog food. We are building our own networks as well. Right. In some of those collaborations we have with them. So, yeah, I hope the NUGs continue. We would love to see more groups. We're always interested in starting groups, just like, coming across you, Eric.
Yeah. Speaking of community, before we go, Chris, where can people find you on social, maybe LinkedIn or maybe somewhere else, USNUA, for example?
That's right. Yeah. So, it's if you want to email me, I'll absolutely respond. It's ckane, Kane, at usnua.com.
Okay.
And yeah, absolutely. You could reach out on LinkedIn. We do blog posts on the USNUA website. Social media, I'm there on X at CCIE 14430.
That's your CCIE number, I assume, not just a
Yeah, yeah.
random
Well,
number.
the one upside about that number is that you can use it for everything because it's unique, right? So,
Yeah.
like, hey, how many times have I tried to come up with some combination of Chris Kane when it comes to like a Twitter handle, and there's 800 others of us. So, yeah,
Right.
I'm nearly guaranteed nobody's going to have that combination of letters and numbers. So, yeah, you leverage the heck out of that number.
Yeah, until Cisco says otherwise. Nobody from Arista. No, just kidding.
Yeah, no,
Back into
yeah.
collaboration.
Well, when you look at that, it's true. I mean, there's an element of upkeep and, is it still active? But the way I look at it, Eric, I mean, it took me several attempts to pass. I think I lost, I don't know how much hair and pounds of weight trying to get through that, successfully get through those labs. And I don't think they're going to issue that number to anybody else. So I feel like I own it.
Yeah. So I should start looking at 2240 and, because there's actually another very famous Chinese pop singer named Eric Cho. So my daughter always give me a hard time on that. Just like, you're nobody.
Yeah, come on, Dad. Leverage that name for something more significant. But yeah,
exactly.
absolutely. Yeah, totally.
Nice. So thanks again, Chris, for being here. I really enjoyed our conversation. I feel like there's a lot to be left on the cutting room here. So, for our listeners, if you do want to dig into any of the other aspects, please leave me comments or, just, shoot Chris an email, shoot us some Slack message, whatever the message is. And we're not hard to find, and just let us know what more you want to hear from us, from Chris. And thanks again, Chris, for being here. I really enjoyed our conversation.
And thanks for the time, Eric. I appreciate the invite.
Thank you for listening to this episode of Network Automation Nerds. Do you have any feedbacks for Network Automation, our guest Chris today, or this episode? Please do send us some follow-ups at packetpushers.net/follow-up. We do want to hear from you. Check out our website at packetpushers.net to find other network engineering-focused podcasts, blogs, YouTube videos, and much more. We thank you, the wonderful listeners, for your support. And remember, if you enjoyed this episode and found it helpful, I would really appreciate it if you could take a moment to leave us a review wherever you get your podcasts. Your review help us help other network engineers discover the show, keep us motivated to bring you more great content like this one. Last but not least, remember that too much network automation will never be enough.